Yes, yes.
Zoom is, compared to
Used to
them, they
Zoom.
are reasonable, and it's okay. It's not that bad.
Okay, okay.
1 second, only one more minute, okay, for the other guy, because they're all completely new one. That's what now, lot of the expectations are very high from the employers, right? So those students, they attended their training from me by year 2018 and 19. They were able to get into a job with the machine learning knowledge itself. Okay, whatever they practiced as part of machine learning, with that itself they were able to crack the interview and they were able to join. But recently also few of my students, right, they cracked the interview with both machine learning and deep learning. But deep learning, though, they asked him not much. The whatever he mentioned in his profile, right, only that they've asked him. Otherwise it was okay, but he was able to crack it confidently by explaining the projects which I gave it to him recently. Okay, that's what. See, now a lot of as I said, right, so Python and other things also you can learn it now. Python became very popular, but especially when you when you look at the job opportunity in USA, still most of the companies, they are using R programming language also. Okay, that is the reason why I cover R also. And it will help, because we work for US customers only most of the time, right? In some cases we work for UK customers, and Canada and German and all, right. Only oddly few projects you will be working on it, right? So you will be working on it. So the point here is Python and all the things, right? I think programming. Those of you have programming background, you can pick up quickly. Any of you, don't worry. Those of you do not have programming background, also don't worry. We'll go step by step. Try to understand the eye level context of my programming. I'll explain you. For example, I'm going to do train and test split. Okay, so don't worry about what is train underscore split, right? Train test split, and what is this package. Don't worry. Okay, I'll explain it high level. High level, you understand that. Those of you do not know programming, right? You just understand the concepts. That is very important. And also importantly, in the internet, right, a lot of especially in the case of AI space, now a lot of frameworks are available, right? For example, in the case of object detection, as I told you, CNN, conventional learning, but the advanced version of CNN, like fast RCNN, faster RCNN, and spatial pyramid pooling, and single shot detector, YOLO. These are the, like, many algorithms are available to solve any object detection related problems. Okay, of these object related object detection related problem, which algorithm is best, which one is right? In that way you will be benefiting it by attending this training program. Okay, so any of will cover deep learning also, right? To start with, we'll understand what is machine learning is all about, what is data science is all about. And those of you who attended my previous batch, you must be able to recollect whatever I discussed. Right? When you don't worry, we'll repeat whatever I discussed in the previous session. But when we cover deep learning also, you will get on like this, right? So what are the platforms are available, like TensorFlow itself, various components are there, different ecosystem components are available, and different framework from different vendors are available. Of these framework, which one is good, right? That and all we'll discuss it. And now we will start with the machine learning part. So what is data science? First of all, let's try to understand what is data science. And those of you belong to the current batch, right? For you all, right, so far we have covered our Python and the statistics part. Okay, and also I gave you the overview at the outset of this training program, right? So what is what is data science is all about, what is machine learning is all about, what is deep learning, what is computer vision, all the things we discussed. Okay, so what is before we discuss about the data science part, right? Let's try to understand what is the 1 second. What is the advantage of learning data science, right? Let's say if you are a statistician, you know statistics, you conduct a statistical test, right? For example, chi-square test. Chi-square test help you to understand, right? Are there any association exists between two categorical variables, right? So you conduct the chi-square test. If the most of the things are revolving around the p-value, right? If the p-value is less than alpha, you reject the null hypothesis. Okay, and if it is greater than alpha, you are not going to reject the null hypothesis. You are going to accept the null hypothesis. This is how, right, you make the decision there, right? Now what we do is we wanted to we wanted to do some kind of what if kind of, see, we need what if kind of answers. It is not like whether age has any influence on buying a specific brand of a mobile phone, right? It is not a kind of yes or no kind of questions, right? We wanted to have answers for different questions, right? If we wanted to quantify something, right, we need to have a mechanism to quantify. For example, if I invest $50 on Google AdWords, Google Ad, right? I know how much increase.
Satya, one minute.
Yeah.
Did you share your screen?
Oh, okay.
Yeah.
Sorry. Yeah. No one told me that. 1 second. Yeah, not able to see, already sent me. Fine. Yeah, this is the thing, right? So $50 if I spend.
You start recording also. You start recording.
Recording, yeah, it's going on. Recording is going on. Thanks.
Okay.
$50 if I invest, what is the return am I going to get, right? So this is, and again, if you ask, let's say if my manager asks me a question like, hey, if I invest $70, right? Or 1 second, this is a big one. So if I invest, 70, let's say, $222. So how much, return I can expect, right? If I invest $222 on Google Ad, how much return I can expect, right? So to answer to these kind of questions, right? And also, let's what is the influence of gender, right? If the male, if it is a male, right? So how much male population are expected to spend if I invest money on the advertisement, right, of the population, given population. Let's how much return I can get. So you can expect return like 10% increase in your return compared to your, if you don't spend money on the advertisement, you're right, you get some money, right? Every month you will have regular income. You wanted to take your business to the next level. So in that case, obviously you have to promote your products or your brand. In that case, you spend money on the advertisement. When you spend money on advertisement to promote your product or service or brand, there should be some kind of improvement, right? But you cannot expect improvement over the night, but you wanted to check, right? So if I invest this much, how much return I can expect, and again if I invest this much, how can I expect? And also, right, 10% of these 10% increase, right, how much the contribution from male population, right? Like these kind of what if kind of questions, right? You need to build a machine learning model, right, with machine learning model. But still you can do it with Anova also, but there are some limitations with Anova test also. So Anova, you cannot have more than three-way Anova is available. Beyond that you don't have anything, right? So if you are using multiple factors, the independent variables, in that case, right, based on the combination of some set of features are nothing but columns, right? So in that case, what how much return I can expect with the combination of some, like this one, gender, and the spend, right? The spend, and this one. And again, somebody, instead of Google ad, TV ad, if I spend money on the television advertisement, so how much return I can expect. So who is the which gender they spend more on this one, right? So by knowing this, whom I can target, right? So if I know of the 10, let's say 10% increase in my revenue when I invested $50 on the Google AdWords, but of this 10% increase, whether male or female contributed, what is their ratio of contribution? If the male contributions, let's say hypothetically 65%, right? So compared to female, these guys are good. So better we can target these people instead of targeting both male and female, right? Because or let's say 70%, right? So majority of the contributions are from male only. Then I can target more on the male, right? So male. So in that case, Google AdWords, you are going to target, in the case of Google AdWords, you have something called image display, right? Image display, you post the banner, you must be asking where is the question of male or female here, right? But again, if somebody wants to know, right, so what is the contribution, but still you can find out, right? Google Analytics, with the help of Google Analytics, you can find out how many number of males clicked your ad, how many number of females they clicked your ad, and how many of them got converted, right? How many of them got converted. Supposing let's say let's say you are launching some or you are embarked into some people, right, Ganesh Chaturthi festival, right? They sell the combo of products, like idol of the Ganesh and other puja items, right? They sell it as a combo, right? So they give advertisement in Google AdWords, right? So how many of them actually they are. So what you do is, by knowing this, you can listen. The majority people are from male, right? See, just by clicking your ad, that doesn't mean they are going to buy. But still, right, the chances, what are the chances that males can buy it more with more confident, right? So what you do is, with the simple data analytics, right, with the Google Analytics, you get to know, okay, more males they click this, and also we got more questions from males, right, compared to females. So the chances are high that if I can make a call to the customer, saying, hey, this is the thing, and if you spend time, right, over call with those people raise questions or contacting the male, right, the chances are that they can order it with you. The chance of conversion is very high compared to female. Oddly few, or few females only visited, then why to call? Let's even though females visited, there are no response from them. Maybe various reasons, right? Because these people are charging the shipping charges and some other traditional thing. Oh no, we have to go take bath in the morning and we have to go and buy Ganesh idol. Various sentiments, right? Due to sentiments also, they may not be ordering it, right? But male, they see, okay, working class people, right? Again, so likewise, right? So likewise, if you want to do analysis with different dimensions, right? So it is good that if you develop a model, machine learning model, you can, right, you can target the right people at the right time. Okay, So machine learning model, right, the whole idea of whether it is a machine learning, in the case of artificial intelligence, let's say artificial intelligence, instead of saying artificial intelligence, this is an umbrella term, right? This is an umbrella term. This is an umbrella term, right? So what exactly artificial intelligence is all about? So in the case of artificial intelligence, right? So the scientists, they thought, scientists and researchers in the past, they thought they wanted to give a brain to the system, right? Instead of writing programs, most of you are programmers, right? You started your career as a programmer, right? So what you do is, even let's say you are working in Excel also, right? Your manager used to tell you, hey, I need this report, based on his condition. You will say between these two date and between these two state data only I need it, right? Do some kind of aggregation, like these two district, Chennai, Kanjipuram, what is the total sale, district wise sales for quarter 1 and quarter 2 comparison, I need it. So in the Excel sheet, what you do is you do something like you do some kind of pivoting, and you generate the report and use some charts, and you generate the report and you send it to them, right? Send it to them. It's all rule based, right? It's all rule based on his requirement, based on his need, or based on the objectives set by your manager, or whatever the requirements given by the respective department, right? Line of business, we call it as a line of business. Instead of saying department, we call it as a line of business. If you take any company, right, different departments will be there, right? You have something called sales department and dispatch, right? They are the one delivering the products to the end customers. And you have something, a finance department. Likewise, various departments are there. Payroll department, payroll is very common, finance is very common. And in the case of manufacturing, costing department, even in the case of the e-commerce, they have cost department, so the pricing department. So they are the one come up with different pricing strategy based on the different seasons and different situations, different periods, right? The price will not be same all the time. So like with different departments, we call that as a line of business. Different line of business or the department have different objectives. Based on their objective, they'll say, hey, I need this report, I need that report. For example, you have an inventory, right? You have something called inventory department. The inventory people, they want to understand what is there, which product we are running, we are going to run out of stock shortly, and which department, which items we need to stock up quickly, which items we need to ship it to other warehouse. In our warehouse, instead of keeping this many number of items, better we will ship it to other warehouses, so that it will not lie idle in our department, right? So these are all their day-to-day operations. This is called tactical need, right? Tactical, you have something called operational, tactical, strategic, right? Strategic need, tactical need, operational need. So operational need are something like, as I told you, right? In my warehouse, certain products are lying idle, and that too huge quantities are lying idle here. Okay, better what I will do is I will ship it to other warehouses, so that if I distribute it to other warehouses, there could be chances we can minimize the stock in our warehouse, right? So for them, it is very much required on a daily basis, especially in the case of vegetable and fruits, right? Grocery items, right? So they are very particular about these reports on a daily basis, right? And similarly, right, different department, right, need different reports. Not all the departments requires operational based reporting, so they need tactical and strategic. So strategic is kind of MIS reports. Those days they used to call it MIS report, management information system. They are very particular about the KPIs, metrics, right? So what is the sale compared to this month and last month, quarter to quarter revenue and sales and cost of goods sold, likewise various metrics, they will check it, right? So all they need is the numbers. They don't have time to go through on the line items, okay, line by line. They don't go through of your transactional data. Instead, they want to get a quick insight, snapshot about what is happening, right? Are we really how about, are we really making progress? Are we really making significant improvement? Yeah, very good, Shanmugam. So you are doing MIS, right? Very good, right? So are we really making any improvement, right? Does our business is really progressing or not, right? So why they need to monitor the dashboard? The dashboard which captures KPIs. What is the dashboard? What is a dashboard? Can someone tell me? Because these people, right? Dashboard is used everywhere in the operational, strategic, or anywhere, even everywhere. They'll be using a different department. The metrics will also vary. Okay, the strategic KPIs will be capturing like revenue, right? Revenue and profit and the cost of goods sold and expenses, right? What is the total expenses? Yeah, tell me. You're saying something.
Customer acquisitions.
Yeah.
So dashboard, what we do here basically, Satya, we utilize a dashboard wherein we get a lot of inferences.
Mm-hmm.
Yeah, which has a variety of data points being covered.
Mm-hmm. Tell me the metrics which you are sharing it with the management, and also you will have some kind of visualization. You have line chart.
Yeah. So basically, so we use, as you said, we use all those four, such as revenue. So customer acquisition, sales cost. Yeah, other than that, repeat customers.
Very good. Repeat customers, okay.
Yeah, repeat customers and like fresh leads. We call it lead basically. Other than that, we used to spend money on social platforms such as Facebook for marketing.
Exactly.
So we check on the numbers, how much they have been spent on Facebook, Google Ads, Instagram.
Okay.
So these kinds of data.
Very good.
Even
right?
the same is like we are also using the same for the same purpose. Satya. Like we report like sales transactions, average transaction value, average daily transactions, number of stores. Like I work for retail domain, so all these things, and again the trend like previous week and this week's trend, like last 3 months, last 4 months, like that we'll be giving trends.
Yes, right. And inventory turnover plus total sales count, product returns also one of the critical parameter, right? How many products in which all category we are getting frequent returns. That is also very critical, because more frequently if you get returns, that also involves some kind that will have an hit on your cost, right? So likewise, gross margin, return on investment, right? ROI and gross margin, and then operating profit. All these things it will capture in the dashboard. Okay. So here, it is not like the strategic management, right? Especially the senior people, they are not interested in which product we are selling it on a daily basis. Which product we are selling more, which product we are not selling well, right? They are not, on a daily basis. They don't want to see it, and they want to see the revenue, profit, cost of goods sold, and like you said, right? Expenses like in the social media, and like Google AdWords, Instagram. Twitter, Facebook, right? Facebook and Instagram and YouTube also. They'll be nowadays. People started giving advertisement in YouTube also, right? The expense, everything. See, the dashboard will give them a quick snapshot about how their business is doing, right? So compare like trend chart, especially trend charts will help them to understand quickly. Hey, are we making progress month on month or quarter on quarter? Right. So in case of any mild dip, right? So why did we not do well? So by performing some kind of RCA, right? So why last month the sale was bad compared to previous month? So by by monitoring and tracking these kind of dashboards periodically, they get to know where the company stands, where we are standing, where we are lacking, right? So and also they do some kind of SWOT analysis. How many of you, I think most of you are aware of SWOT analysis, strength, weakness, opportunity, threat. Right? You do this one, right? So you will be looking at this one. The management, they are very particular about these reports. Okay, strategic report, like tactical report, very specific reports, right? Some department, they need a specific report, some ad hoc report, right? Suddenly they found some problem, they wanted to generate some reports, they want to check where the problem is. And the operation reports, right? Day-to-day transactions, day-to-day operations, right? Different reports we generated from the organizational point of view. So these are all the predefined reports. Apart from this, see, these reports have been generated for quite a long time, right? These are all not new one to the companies. What management they wanted to know, these reports, right? These reports gives an idea about what is happening currently, what has happened in the past. Now, management, right? Organizations, now they don't want to rely only on these reports. Okay, they want to go one step further and to know what is going to happen in the future. What is going to happen in the future? That is where the predictive analytics is coming into picture. Predictive analytics is coming into picture. Right? Predictive analytics. So predictive analytics is nothing but using machine learning algorithm, we can make a prediction. Using machine learning algorithm or deep learning algorithm, we can make a prediction. Okay, so then what is artificial intelligence? Artificial intelligence, as I told you, so instead of, so these reports are rule driven, right? Rule based reports. So if this is, if the formula is this, then, you compute as per the formula, you take the data and compute it and, plot it here, plot it in the chart. These are all predefined, right? And I don't want, the predefined thing. Apart from the predefined reports, is there any way the system can think on its own and can help me to put some spotlight on the interesting stuffs which buried in my data set, right? We are dealing with humongous amount of data nowadays, right? Petabytes and above volume of data. You take any company nowadays, the volume of, even in our WhatsApp, right? Most of the people I could see, they are using 2 WhatsApp and they use 2 different WhatsApp numbers, and their mobiles are filled with a lot of videos and audios, many things, right? Images. Right? So similarly, you take any organization, now the data volume is very high. The data is available. Now we are data rich, but we are not information rich, right? So hence, okay, they write these predefined reports, and they use, some people they use Power BI, some people they use Tableau, and some people they use SAS, and different reporting tools are available. With that, they are able to generate these reports to fulfill each line of departments their objectives or requirements. But apart from these predefined reports, is there any other pattern that can be found from the data, right? And also, is there any way I can predict the future? Because these reports give me a snapshot of the current and past, but I don't want to rely on the current and past alone. I want to go one step further, and I need to understand what is going to happen in the future well ahead, so that I can mitigate the risk. What the other, if you get to know well ahead, right, something is going to happen, what is going to, right, you can plan well, right, you can plan well. For example, next month festival is there. Okay, customers are going to buy so and so items. Those items are more relevant to the thing. And also, if I wanted to know the amount spent by the customers, what is the expected amount spent by the customers for the next 2 to 3 months, how will you know that? How will you know that? If somebody is asking you, okay, can you give me the spend by customers, right, last 1 month, can I see, let's say, potential customers. We don't want to see, listen, my customer base is very high, I don't want to see all the customers, right? Those customers spend more than 100,000 in the last 2 months, right? So listen, we have some cutoff value, right? So 100,000, we call them as a potential customers. So these customers, of these customers, right? Let's say I have hypothetically, let's say 25 potential customers are there. They are purchasing more frequently, and also they refer more people, and they don't return the items also frequently, and their spend is also more than 100,000, right? Every 2 months, right? We say, oh, these 25 customers are, since these customers are falling in these categories, we call them some potential customers, 25 potential customers, right? So we don't want to miss these potential customers. We need to come up with different pricing and offers for these potential customers in order to retain them, because they are the when frequently purchasing the products, and that too they are spending more, and but their return is also very less, and also they are loyal customers. They bring different more customers also to my business. I don't want to miss that. So in that case, you can plan well, right? So, or you can predict well, right? So how much they are going to spend in the next 3 months, and also what kind of offers you can give it to them, right, in order to retain those potential customers. Okay, fine. So apart from this, right, we have you can mitigate the risk. Supposing in the case of inventory or in the case of customer churn, right, I don't want to lose my potential customers. So before even my customers walk out of my business, is there any way I can get to know their pulse or get to know their sentiments about my products and services, right? If you get to know, you can talk to those customers. They are really desperate with your products and service, right? You can contact them well ahead and tell them, right, understand their problem and try to resolve their problem, and and give them the assurance that the same issue will not recur for them. On top, right, give some discount, right? So since this is a problem from us, next month we are not going to charge you for any value added services, right? We are not going to charge anything for the value added services. It will be free, absolutely free. So in that way the customer will be happy, they will continue with you. If you don't take any measure, right, so what will happen is the customer will walk out of your business. We call that as a churn, right? A different company and different people use attrition, employee attrition, you might have known, right? So instead of saying attrition, some people they use the term churn. Customer can churn your business, right? And also we can find out the customer sentiments using the text data. Text data are like the unstructured data. So unstructured data, see, nowadays we are getting more unstructured data compared to the structured and semi-structured data which we used to get it in the past. Nowadays the unstructured data are more compared to the structured data, and these unstructured like text data, like the social media site data and the customer feedback, whatever they gave it in my website, these data are not structured ones. Some people they would have used emoji, right? Some people they must have used some slang or abbreviation, right? See, some people say IDK. So what is IDK? I don't know, right? So you should be able to understand. You should have some mechanism to understand all their languages, and by understanding that, you will be able to understand the customer sentiment. By knowing the customer sentiment, you can act proactively, find out the customer. With this data, you will be able to you don't have to call the customer. With this, we have something called NLP, natural language processing. Okay, this is also most sought after skill set, natural language processing. But don't get confused. In the past, one guy attended the training with me, and then this is some neuro-linguistic program. Okay, without even asking me, he went and paid some money to this training center. Okay, and then he attended this one, and he started telling me, sir, before even you covered NLP, I attended NLP side by side. So I thought, okay, who is covering, what is the fees, everything. It is a neuro-linguist, sir, very interesting. I thought, man, it is not machine learning credit, that is different, right? So okay, so that, but using NLP, right, natural language processing, you can pre-process the text data, and then you can extract the meaningful information from these data. With that processed data, or the the meaningful information which you recorded, which you extracted from this processed unstructured data, you will get to know, oh, these are the customers, they are very angry, right? In my they called my call center and they shouted, all this, the data got recorded, and customer was very upset, and some customer used to say, okay, you can escalate it to your management, I'm not happy with. In the case of bank, right? So some customers say, no, I kept some money in the I reserved my money in one account for capital gain, other account I use this one, but end of the day, right, everything, certain things are manual, I'm not happy. Different customers, they voice their concerns. Those concerns are recorded here, right? So these data on some customers, right, they don't even call us, they go and put their comments, right? Somebody is asking in Facebook or in the WhatsApp group, they'll ask, hey, what is your experience with so and so product, right? I purchased the so and so thing, let's say air purifier from Philips, I saw LG. So what is your experience? Okay, after I use this one, I don't see any improvement here. Still, I have the allergic reactions are there. They go and post their comment in the WhatsApp group or in the social media sites. We extract those comments also with that comment, right? But they post the comments in social media, everything, but they don't use the proper English words, right? They may use abbreviations, they may use emojis, right? With this, using NLP, right, we can extract the meaning from these kind of abbreviations, emojis, and other things also, right? And then we can understand proactively, hey, so and so customers are very upset. Better you call and understand. Though they did not give any feedback in our system, but in the social media they are very upset. What we will do is we will go ahead and respond to them promptly in YouTube, or nowadays the companies, they respond in the social media itself, right? As soon as they see the customers feedback, right, they go and respond it. So let's say in the YouTube, they promoted their product with video ad, and the customer was not happy, they would have put their comment there, right? So immediately they responded, extremely sorry for your issue, and we will definitely reach out to you and will sort out your issues, right? So apart from this, right, we'll try to find out proactively using this NLP technique, find out the customer sentiments. If the customers are not happy, contact them proactively and try to retain them, right? By coming up with some retention strategies, try to retain them. This is very simple. So before things go wrong, right, if you proactively act on it, and if you are able to find out what can go wrong well ahead, you can come up with a mitigation strategy, right? For other example is like before I run out of products, right, so and so fast moving products, I know, right, I'm going to stock up more. And let's say in my area, some or the usual, the regular vendor, right, who used to send the raw materials to my warehouse, in that area riot is going to happen, right? For the next 2 to 3 days, we expect some riot can happen. So what we will do is we will we will go to some other alternative vendor from other city or other nearby city to order the product instead of ordering it from the regular or usual customer vendors. Okay? So when you get to know what is going to happen well ahead, right, you can mitigate the risk. See, risk is very common nowadays. Everywhere risk is there, but you need to have some. You need to predict the risk also, right? We use probability, right? So in that case, if I know well ahead how much I can mitigate, fine. So using machine learning model, we can predict the future, right? How, even the case of stock market, right? Stock market also same thing, right? But let's say I have substantial amount is there in my hand, right? Let's say recently I sold few of my employee stock options, right? And I have some amount with me. I just want to invest it in stock market. Why should I invest the money in stock market? I wanted to get some returns. I want to make some profit out of the money what I have it, right? So in that case, I want to be very, very cautious, right, before investing my money on the stock market. So now we have IPOs, right, long-term plan, an intraday can I spend it. Likewise, we plan it, right? But before we invest it, we make a forecasting, right? We do some kind of forecasting. So which shares can go well, right? And which IPO, if I invest so and so money, how much return I can expect, right? Those kind. Even in the case of healthcare, right? So which customers are more likely to develop malignant tumor or cancer, right? So you are going to predict everything. So before the patient dies, right, or before the patient develop heart attack, right, if you have a mechanism to predict, right, which all patients are more likely to develop heart attack, right, so you can suggest them, right, you can if you have some mechanism which can help you to predict of these patients, right, these customers are high risk patients. So what we will do is we will tell them strictly, hey man, you have to strictly make some changes to your lifestyle. Stop eating fast food and other things, right? So on so thing. Do exercise. Likewise, eat hot healthy, hot friendly fruit, something like that, so that you can postpone the problem. So even the case of healthcare also, it helps us to make a prediction, to life saving, right? In the case of patients, right? It helps the doctors also to understand which customers are more likely to develop. See, some people, right? They'll be very good. They say everything all right, but only when they go for some accident, right? Some face related problem, ear pain. Doctors say your ear got infected. Better you take ear with the brain scan, right? They went for ear scan, but ear problem. Along with that, they took the brain also. But they say small in your brain also there is a small lump is there, right? And ear also some problem is there. Doctors say you went for ear thing, but they say yeah, ear is also fine, but this is something the cause for concern, right? So now with the historical data, we can predict whether this is a malignant tumor or is this a benign tumor. It doesn't mean if you have lump, that doesn't mean you are high risk patient, but still they get to know that, okay, so for this, if they have some treatment or something, they can suggest, right? So you will be very proactive, right? So, and again, what are the chances that given your size, right, what are the chances, even especially in the case of heart patient, you would have known, right? So they must be having some block in their heart, and they will say, okay, this is just for 5% only your block is there, but they can predict, right? They can say probably in next of 2 years, your block size might increase it to 25% or 35%, right? They can predict it. But if you follow strict diet, everything, so it will not progress. You can control it, right? So likewise, healthcare and stock market, even the case of inventory, supply chain management, right? Supply chain management, SCM, and everywhere. See, nowadays, everywhere, artificial intelligence is used, right? We are using artificial intelligence umbrella term, as I told you, using the whole idea of artificial intelligence to make the system to mimic the humans, make these algorithms, give the artificial intelligence instead of giving the human intelligence, giving the artificial intelligence to the system. System should make decision. The classic example is self-driving car. Self-driving car. When the car drives on its own, when it encounters any hassle on the road, on the en route to its destination, it should make decision on the fly, and it should react accordingly. If the car does not react quickly, what will happen? It can go and hit the object or person, or it can hit the wall or other vehicle, right? Everything should happen nowadays, right? Real-time prediction is there everywhere, right? Everywhere they implemented the real-time prediction also. Okay. Even the case of bank, right? Real-time prediction, right? So sometimes, right, the customer, most of the time they used to spend their money in a specific location in India, and suddenly they could see the same customer is spending money in other part of in India. Like somebody is in Delhi, right? Listen, you most of the time you spend money in Andhra and Tamil Nadu, but this time your card was used in North India, especially Uttar Pradesh or somewhere. That too, the spend was more, right? So since the bank also, right, they implemented machine learning algorithm, it can proactively find out, based on the patterns, right, based on your spend pattern. This customer used to spend most of the time less than so and so money. This time the money spent is also very high, and that too the location also different. It automatically alerts the customer. You spend, right, automatically email comes. In case of any if this transaction has not been done, you can contact us immediately for dispute, right? So likewise, right, proactively it alerts us, right? So the classic example is self-driving car, right? The real-time prediction. I was talking about real-time prediction, right? Real-time prediction. It should make a prediction. Let's say the car is driving on the en route to a hotel, right? Let's say from your house to airport you wanted to go, right? On the en route, if any livestock, any animal crosses the road, out of the blue, right? Suddenly something is crossing. Your car should be able to understand what that object is all about and how to react. Whether should I take the diversion or can I prepare to stop the car or stop the car. Otherwise, what will happen? Both the object as well as this one will get damaged, right? Some calamity can happen. So that is where the real-time prediction is used in the case of car. Without the driver's presence, right? The car itself. See, here we have given the brain to the car. You remember this? We have given, using artificial intelligence, we have given the brain to the car. Like how a human driver can decide, where to, turn the vehicle and where to prepare to stop the vehicle, when to, move the vehicle. Even in the case of say signal, right, traffic signal, whether the car has to stop or it has to move, right? Everything has to be decided by the car itself, like how a human driver decides, right? So we have given the brain using the artificial intelligence to the system. In this case, the system is car. That is what artificial intelligence. So as part of artificial intelligence, there are two branches, right? So one is machine learning. Yeah, so machine learning, and we have something else called deep learning. So deep learning is an extension of machine learning algorithm. You just think that way, okay? You just an extension of machine learning algorithm. So right now you know what is artificial intelligence. It's an umbrella term, and we have given the brain to the system in simple term. So ML is used to make a prediction, to predict the future. We use the machine learning algorithm because these algorithms have inherently, right, it has the capability to find the pattern from the data, hidden pattern in your data, right? It can find out automatically, right? That is the beauty of machine learning algorithm. Something which we never thought about it. So these reports were, right, like dashboards, all the metrics. You have 25 KPIs or 30 KPIs are there, and a lot of charts are there. Fine. So, and also different departments that need different reports from these operational point of view, tactical point of view, strategic point of view. They need different reports. So these are all the predefined thing. So apart from this, right, is there any other thing, any other pattern that are lying in my data set, right? And also, can I predict the future, right? So that is where we use ML algorithms. ML algorithms has the capability to find the patterns from the underlying data. And the deep learning is gained a lot of popularity, right, recently, in the past few years, right? It gained a lot of popularity, and the deep learning algorithm evolved from machine learning algorithm only. So in the machine learning, we have something called neural network. This is very important concept. I used to spend a lot of time in neural network, right? All the derivation, everything I used to explain. Okay, so because what they did, they improved the neural network. Okay, they improvised the neural network. It's something like, right, you have Windows 7. I don't know how many of you used Windows 7, right? And now we have Windows 10, right? So Windows 7 to 8 they made some improvement. Likewise now we have advanced version of. You just think that way. It is an advanced version of your neural network. The deep learning. So why we need to have a deep learning algorithm? So what can we do it? Here also we do prediction, right? Here also we do prediction. We do image classification, image recognition, object detection, and image classification, object detection, and object segmentation. Right, likewise, right, and also we can do forecasting also, and using nowadays we have RNN algorithm. Using a recurrent neural network you can do forecasting, and you can do sentiment analysis also with RM, and also you can find out next best word in the Google. I don't know how many of you, I think all of you must have known this one. Let's say in the Google search bar, right, you must be best air purifier. If you type, right, when you type in, automatically shows Chennai, Bangalore, something like that, right? So the next best word is automatically. Even the case of Gmail, when you when you compose the email, right, automatically it shows you the relevant, the next best keyword. It's not based on the previous word, based on the entire sentence, right? It can give you the appropriate next best word which you can use it. Right? It's all possible because of the recurrent neural network and other deep learning related algorithm, especially when you have huge volume of data and importantly image, video, audio related data, right? And we have something called speech recognition. So Alexa, no one can say I don't know Alexa, right? Alexa. So a lot of advertisement is also coming, right, in the YouTube. So if you ask the device, right, if you buy an Alexa, and if you tell Alexa, hey Alexa, can you book a flight for me next month, so and so date, it automatically books it, right? We don't have to go to the website, we don't have to do it manually. So whatever the work you do it, right? So all you did was you just instructed, you gave the instruction, voice, right? Hey Alexa, can you please book a flight in Lufthansa to go to USA on so and so date, right? It automatically goes and checks. You don't have to worry which one is the cheaper price, and which route is the cheaper one, and which route is shorter one. You don't have to worry about this, right? It automatically goes and book the ticket for you. If you tell the your budget, everything, right, accordingly it goes and book it. Alexa. Right, so these are all because of deep learning algorithm, right? Voice recognition, and even nowadays voice bot, chat bot is also very popular. Chat bot, right? So you must have heard about. Even the case of bank, many banks they started developing chat bot also, right? Chat bot, human presence is not required. So you can go and ask any question with the bot. It can answer to you as though like how a human can respond to you, right? Let's say you want to go for a personal loan, and if you ask, I'm looking for a loan, personal loan. If you type it, it automatically understand your question and the context also, right? And then it gives you the relevant answer. So what is the duration? It will ask you the question, what is the duration that you are looking for it, right? And then if you ask what is the interest rate, it gives you the interest rate. And for different duration, what is the thing? Can you give me for different duration what is the interest rate and EMI that I should pay? Tuck, 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 it gives you everything. Different banks, they use different chat bots. Right? These these chat bots replaces the human's presence. Right? 1 second here, I'm getting some noise here.
Sir, I'm not able to hear you.
He's actually got some thing. I guess he'll be back in.
Sorry, I got some interruption here. Okay, I got someone was waiting for me. Fine. So likewise, right, with the deep learning, you can make advanced, predictions, and you can do image recognition, object detection, object segmentation. We'll take a deep dive. So different frameworks are available nowadays, even for deep learning algorithms, TensorFlow and PyTorch, Theano. Likewise, different frameworks are available, and even for object detection, different algorithms are available. Okay, we have some RCNN, fast RCNN, faster RCNN, SSD. Likewise, different algorithms, or YOLO. YOLO is also very popular. Of all those, which one is better, right? Which one is better? Which one should I use it? Everything will see it as part of deep learning algorithm, right? So deep learning algorithm is used to work well. We use deep learning algorithm especially for image recognition, right? Speech recognition, everywhere we'll be using it. Okay, object detection, everything, right? For these purposes, we'll be using deep learning. Even within the deep learning, different algorithms are used for different purposes, right? CNN, we use convolutional neural network. So convolutional neural network is convolutional neural network. This is meant for image classification, right? Image recognition and all. We'll be using CNN. RCNN will be using it for object detection and all, right? Regional convolutional neural network. Likewise, faster RCNN. Likewise, different. I don't know how many of you watched my today's WhatsApp status, right? Probably you can go and check my WhatsApp status. I put all the frameworks, top algorithms for object detection, top algorithm for face recognition also, right? Deep face is also a very popular algorithm or API that is used to do the face recognition, and the Microsoft computer vision is also a popular one. And again, right, so they put the accuracy along with those algorithms also. Okay, for example, in the case of Inferdo, the accuracy is 100%. If you throw all the images, right, it can tell you accurately these images are related to so and so. These images are related to dog. These images are related to cat. These images are related to rabbit. Something like that, right? It correctly, even though certain breeds of dogs looks like cat and certain breeds of cats looks like dog, right? But still, this one correctly classifies. But when I used in the case of object detection, right? In the case of object detection, I have used something like the SSD. SSD also, it is not doing that great job, right? Sometimes even the case of object detection, many algorithms are available, right? So certain algorithms, so you can do annotation also, right? So you have some kind of images. You are given 1 million images. They want you to annotate the objects that are in each images with annotation. Now even for videos, right, in the video, let's say you have a scene, right? Let's say there is a scene in the video. You and your wife and kid, and you are crossing the road along with your pet, right, a dog or cat. In USA, you have a car here, right? Behind your car, many cars are there. These are the scene, right? So when you in the video, it captured everything here, right? So but you, even for a normal human being, right, we might see our car and we see both sides of the road while crossing the road. We don't see other things. So maybe we might see what is behind this car. That's all, right? And that's all. You cross the road. But in case of any issue happened, right, when they replay the video, let's say some crime happened in that scene, right, after you crossed or just before you or just after you crossed that place, right, left the place, some crime happened. When the police, when they see it, right, it automatically tells, you put the annotation also, this is a car and this is a car, is human, and the here some human is standing here. But even you might not see whether human is standing or not. It automatically put the the bounding box, and also along with it put the annotation also. Even in the case of video, right, annotations, bounding box are nothing but the object detection thing, right? So all these things are possible with deep learning. We'll take a look at those things a little later. Today we'll start with the machine learning part. So now you understood deep learning got evolved from neural network algorithm, which is part of the machine learning algorithm. So in the case of neural network, they made some breakthrough to improvise this algorithm further. Right? So one classic example, convolutional neural network. Using convolutional neural network, you can do image classification or image recognition. Even in the case of self-driving car, they use CNN, right, to classify whether it is a red color. In the case of traffic light, right, whether it's a red light or green light or amber light, it has to classify. The algorithm has to classify. Oh, okay, this is a red light. Okay, it based on which the algorithm will instruct the car, hey, you need to stop. The car will stop it. This algorithm is CNN. Okay, and along with they used reinforcement learning and other thing, but this is also one of the algorithms that has been used in the case of self-driving car also. Okay, fine. So the next thing is computer vision. What is computer vision? So deep learning and machine learning, and what is computer vision? How many of you watched my status, WhatsApp status? A few days back I put the difference between computer vision, the machine learning, artificial intelligence, right? Machine learning and computer vision, deep learning. Using machine learning also we can implement computer vision. Using deep learning also we can implement computer vision. What is computer vision? I'll ask you one simple question. So let's say, so nowadays, we don't need a driver to drive a car, right? Because you use artificial intelligence and you gave the brain to the car, right? The car with the brain, whatever we gave it, it can drive, it can make decision, right? On the en route to your destination, it can make decision whether it can go straight, or if the traffic condition is too bad, which alternative route should I take? Or in case of any livestock or anything crosses the road, right? How should I react? Okay, you gave the brain and you gave a beautiful car, right? This beautiful car has all features, and you have given a brain. Is that sufficient for the car to drive safely? Okay, you have everything in the car. Okay, you have everything in the car. But still, brain alone is not sufficient, right? Vision is required, eye is required. How will the car get to know whether any livestock or any animal is crossing the road, or how will it get to know? Right? Or any car which is crossing it, suddenly, right? In a nick of the moment, some car, suddenly they turn the car here. How will the car get to know? It needs some vision, right? Brain alone is not sufficient. It requires some kind of eye, right? Vision. It requires a vision. So what they did, that's when the computer vision, the implementing the concept of the computer vision has been conceived. Now with the vision, the systems can perceive, what is crossing the road, what is ahead of my car, or what light is there in my traffic signal, and whether I should cross can I use the same route, or can I take the alternative route because of the traffic condition, right? So again, the eye vision has been given, right? That's when the computer vision is coming into picture. Along with the brain, we have given the vision also. With the vision, now the systems can see the world like how a human can see the world. Now the systems can think like how a human can think, and also it can see what is around the system, right? Based on which it can make the decisions accordingly, right? You can use machine learning, and you can also using deep learning algorithm to implement the computer vision algorithms. So now hope you understood. See many and now the question is, what is data science? data science encompasses everything, right? Data science, it not necessarily should know everything, okay? And if you know machine learning, that is enough. But you know very well, nowadays even freshers, right, they knew what is machine learning and deep learning. And that's what in a group, right, I just asked a few guys. One guy, he answered very promptly with high enthu, right, saying that, hey, I worked in SSD, and I worked in YOLO, and I worked in RCNN. So I liked RCNN and YOLO. I don't like SSD because in SSD it took longer time. So I was surprised, I asked him, hey, what is your experience? He said, I'm just a fresher. Okay, so to cut to the chase, data science encompasses everything. Okay, artificial intelligence. If I say, data science is nothing but artificial intelligence, which implies that it has artificial has a branch of ML has a branch of DL. Using these two, you can implement computer vision also. Right? Fine, it encompasses everything. But if you know everything, it is good. That is what is expected from the industry. No matter what your experience, experience you have it, they expect you to be good at everything, right? In every algorithms also. Okay, fine. So don't worry. We will go through the algorithm step by step, and each algorithm also will take a deep diver. Okay. So now let us start with understanding what exactly machine learning is all about. Machine learns, that's all, right? Machine plus learning, machine learning. Human plus learning, human learning. But human learning is different from machine learning and vice versa. So we learn the language. Supposing you want to learn, how we learn the language, right, from our childhood. Our mother tongue, could be different, but our, state language is different, right? So how did we learn both the languages? From our parents, right? Our mother used to teach, hey, this is called a spoon, right? This is called a spoon, and this is called elephant, right? This is called a big ear. This is called elephant. This is called a spoon. And right, this is called elephant, right? And this is called giraffe. Giraffe is something like, right, big neck will be there. This is called your giraffe. English also, right, they taught us like this. So this is called elephant, this is called spoon, this is called giraffe. This is how we learn the language. Parents, by listening from parents, friends, neighbors, from teachers, we learn all the things, right? We learn from them. But can a machine learn from other people? No. Machine cannot learn like how the way human can learn. So in the case of machine, what do you mean by machine? Machine is nothing but the algorithms. These algorithms were already invented by scientists. Okay, in the past, we don't have to invent new algorithms. Okay, fine. So in the case of algorithms, which is nothing but the machine, how it can learn the patterns, right? How it can learn the pattern, right? So in the case of machine learning, you need to train the algorithm with the data, historical data. You need to use the historical data to train this algorithm. You need to teach the algorithm with the data. Which data? Historical data, last 1 year data, huge volume of data, 1 year data or 10 year data. And don't ask me, mine is startup company, what can I do? Then you cannot train your algorithm. If you have less data, there is no point in training algorithm. Obviously it will not have patterns in it. Your accuracy will not be good. Okay, let's say your company, you launched your company, right? You started your company and almost 10 years back. You can use 10 years data. In the case of bank, right, 10 years data you can use it. That is your historical data. Train your algorithm. You just feed this algorithm. You tell the algorithm, so this is the historical data. The algorithm, what it does is, it has capability or intelligence to learn the pattern from this data automatically. It learns the pattern mining. That is what they say, pattern mining. The machine learning algorithm. Yes, Shanmugam, go ahead. You have a question, right? Yeah.
Yes, Satya. So actually, I was about to ask this one. So when you said when we are going to start a new company or something, and they would be having no historical data, right?
Yeah.
So in that case, let's say I'm starting a company wherein a similar kind of a company has been running before, or maybe some algorithm has been implied in some of the GitHub or OpenAI sources. Can't we use those OpenAI algorithms for this and try to fine tune after that?
Yeah, you can use some pre-trained models. Okay, you can use pre-trained models, but you cannot use others' data, right? You cannot use others' data to make a prediction. That's a very good question. That's a very good question. Yeah. So what your point is? Okay, already I trained my model with other companies. Like, you know, my brother's company was there for 10 years, like Anil Ambani, Mukesh Ambani, right? So my brother started 10 years. I'm also in the same business, but I started a new company. Can I use his model to make a prediction? Is that what your question?
That is the model, right, sir?
You know, this is a little bit different. I will explain you what is pre-trained model, you know, as part of deep learning algorithm. We have something on ResNet, GoogleNet, MobileNet, AlexNet. Likewise, different pre-trained models are there. That concept is, you know, slightly different. This is different, okay? You know, you cannot take your brother's business because your brother started his business 10 years back, right? Or let's, you know, take for example, first of all, security issue. You cannot, you know, use his data, or you cannot use his model, right? You cannot use the security related issue. Number one, any of you say that is my brother, I'm not going to use his data. I can take his model, I can deploy it there, but still when you deploy the model, right, you need to have this data also, right? You need to have this data also, right? That issue, and you cannot do it that way, okay? So you need to, you know, train your model with your historical data, because you are going to you know, predict about your customers pattern, right? Your customers pattern. And you might be asking this question in the case of bank, right? Let's take for in the case of bank also, most of the banks process are somewhat similar. Can't I take other banks you know, algorithm, and can't I, you know, still different banks, they have different process, offers, everything, okay? So we cannot simply take it and we can, okay, let's say both the banks, you know, business are same. My brother also into milk business, I'm also into milk business, right? So both of them are into same business. Can't I use this model, right? Still it is not advisable, right? You can take your data, historical data, you can, because your business strategy, your marketing, everything will be different from, you know, your brothers, right? It's all different, completely different. You cannot, and again, you know, you started 10 years back, right? Now your business, even the case of retail and all, right? We don't take 10 years of data and all, we take 2 years, because it's very dynamic. The prices are keep changing. There is no point in taking 10-year-old data, because most of my past customers would have gone out of my business, right? So we take the, you know, recent data. Again, in the case of retail, big box, right? The big box retail is, the volume of the data also very huge, even though it is just a 2-year-old of data, right? So in simple term, okay, what we do is we need to train the model with the historical data, right? Train the model. So once this model has the capability to learn the pattern automatically from this historical data, so then what you do is you apply this model on the unseen data. You need to take your historical data, your company's historical, not other company's historical data, because company to company, obviously, right, the strategies, marketing, pricing, everything will differ, okay? And right, so in that case, you need to take your company's historical data, train your model, and then you apply this trained model on the unseen data to make a prediction. See, in the case of this is my machine learning algorithm. I told you in between, right? This is my machine learning algorithm. This is my machine learning algorithm. I trained my machine learning algorithm with the historical data. This algorithm has a capability to learn the pattern from this data, and then if I use this algorithm, apply this algorithm on this unseen data, it can make a prediction automatically. See, for this I will give you one simple analogy, okay? With this simple analogy, you should be able to understand how the machine learning algorithm works. For example, this is my ML, right? ML algorithm. In the middle, you have some historical data, something like, you know, your father taught you, right? Your parents taught you, parents. And then what you do is, in the future, when you encounter similar problem or similar situation, right, whatever your parents taught you, right, you apply that. And then you will take a decision, right? You are going to predict. Okay, the classic example is, your father was in a lending business, right? Let's say, take my case, right? My father was in a lending, just for hypothetical case, okay? My father was in a lending business, and he used to give loan to many customers, and he had a different experience with different customers in the past. And before his death, right, he taught me everything. These are the experience. A customer with less income, and if he already has many loans, right, more than one loan, or even if he has one pre-existing loan, don't give him loan, because he defaulted in the past, right? So this experience, right, this is the one cap has in my historical. This is a pattern, right? My machine learning algorithm automatically finds it. How it will find out automatically? We need to tell the algorithm, right, this for this input, and this is the output. You need to tell the input and output upfront to this algorithm as part of your historical data to the machine learning algorithm. The historical data should have both the input and output. Input is something like, output is only one variable. It will have yes or no. With the input, you will have age and income, any pre-existing loan, how many number of times his account got delinquented, right? And how many number of kids he has, marital status. All these combination of multiple columns, right, are called input, and only one column is output. So the customer with so and so income and so and so pre-existing loan, and so and so EMI, right? EMI also matters. Okay, so this is the loan amount, and this is the EMI is paying it, right? And he is a married guy, and he is a jobless guy now, right? So it automatically finds out, right? We need, right, for this kind of thing, right? We already recorded in the past. We already manually recorded. So these customers defaulted. This customer did not default. This customer did not default. These customers are profitable customers. This customer non-profitable. We maintained a data set. We recorded this in our data set. With this combination, these are the output. So this customer is defaulter. No means they are non-defaulters. They are married and their income is high, and currently they are employed, and they have secondary income also, right? And both husband wife also working, they are non-defaulter. So the algorithm, if you give both the input and output like this, it automatically finds the pattern, like how our parents taught, isn't it? Right? The same way it automatically deducts the pattern. Oh, a person with less income, yes, and with the so and so thing, right? Jobless, and he has more loans, and he is more likely to default. And let's later point in time, when you apply this, now the algorithm learned the intelligence by learning the pattern from this, both an input and output data of your historical data. When you apply this now on any new customers, those applied for the loan, it applies the same pattern there. Hey, if the customer with the so and so income, right, and whether his employment status is no, that means he's not employed currently, and he has pre-existing loan, as a monthly EMI is this one, and with this guy is going to default. See, likewise, right? Let's say you have friends. Your parents already told you, right? If your friends are not working, before you give the loan, first ask them whether they are working or not. Okay, whether they are doing business or not. They are not doing both, then don't give them loan. Even though he is your very close friend, don't give him the loan. These things taught by my parents. Let's say that way, okay? So in that case, what I will do, if any friends comes, and even though my close friend is approaching me for a loan, right? I'll ask him, hey man, you already earn more. Why you need a loan? No man, I lost my job. Since when you lost your job? Almost a year back. Then there is no point in giving loan to him, right? It's the same thing, same way, like how our brain, right? Our brain process, right? Our brain applies the past experience on this guy and decide whether this guy is going to default or not. The same way the machine learning algorithm works. The same principle is used in machine learning. It learns the pattern, but you need to specify the input and output, right? Customer with input data is obviously you have the customer data, right? As part of your loan application form, you would have got all CIBIL score, everything, right? And you maintain everything as part of these columns. And you for each customer, against each customer you mentioned, right? This one also, this is yes or no, no, why, input and output. If customer is so and so thing, and they are defaulted, they defaulted in the past. This customer they defaulted, right? So now my model, if you give this input and output to this machine learning model, it automatically learns the pattern, and then it can apply this on the unseen data. See, to answer to your question, right, Shanmugam, the CIBIL rating, right? CIBIL rating, they have different thing, right? Right. So somebody is not paying on time, credit card, loan, they don't frequently, they are defaulting, right? So this is so before giving the loan, right? CIBIL is also one of the important thing, right? CIBIL rating. So they see, okay, the CIBIL rating is very bad, we cannot give the loan, right? So there already they used some mechanism, right? Some mechanism. If customer, they use some, they use some model, predictive model. With that, they arrived this one, right? So in that case, yes, we are using that one as a basis, but still we don't rely only on the CIBIL thing. Apart from this, we look at various other thing also, right? Various other things. So what is this? Probably is CIBIL for the last 1 year or last 5 years, he did not borrow any money, and is or even though he borrowed money, he made the payment promptly. Currently, there are no loans against him. But CIBIL, because of this, his CIBIL rating is very good. But last 2 months, he is out of the job, right? And also, right, 2 months back, he conducted marriage to his daughter. In last 2 months, because of which, right, he spent all his savings, and right, currently he is not working for the last 2 years. But still, this customer is a risky customer. Am I correct? So in that case, Arun Kumar is there on the call? Or I don't know, Arun Kumar joined. Yeah, good. Arun Kumar.
Yes, I'm there.
Yeah, Arun Kumar. So in that case, right, can you simply rely on the CIBIL rating?
No, we cannot directly rely only on CIBIL rating, because we have to consider the other factors also. Like the marriage is also poor, and he has completely cleared all his savings, and also we cannot give him loan. It is a big risk for the bank.
So that is also the bank, they ask the recent salary account, right? A statement, bank statement, right? Bank statement also very important. Maybe his CIBIL rating is good, so far he did well, everything. Maybe he is a very good guy, genuine guy, but last 6 months he is not, he developed some disease, post-COVID effects are there, he is not earning well, he is not earning at all, he is spending everything from his savings. And also 6 months back he conducted marriage, because of which also he became bankrupt now. But as the CIBIL is concerned, it is good. But when you apply for the loan, obviously they'll ask, are you a salaried person? Right? First question itself, right? If you say I'm not salaried, they will decline. Simply they decline, right? Likewise, right? We simply cannot go by the CIBIL rating also, right? Or let's say last 6 months, he was not going to any job. Recently he joined the company, right? But still they ask for last 2 months bank statement, right? 1 or 2 month statement. They will say what is his current salary and what is his past. Recently he joined the company. I don't know how long he will continue this job, right? And again they don't check medical, and again they will see age. Age is also a factor, right? Will you factor into age, Arun?
Yes, definitely we have to consider the factor age also.
Age also, right? Age and other assets also. Whether he has any, in case of any default, right? In the event of default, how we can recover the money, right? So bank will think everything well ahead, right? So in that case, obviously credit risk, we need to do, so we need to see, that's what this example, okay. The machine learning algorithm, to answer to your question, Shanmugam, the CIBIL rating, right? So they used with the various criteria, various faint pattern. Still we use that one, but we are not simply relying on the CIBIL rating alone. Some cases the CIBIL rating will be good, but as I quoted some points, right? We cannot simply go by that also, right? Pre-trained thing. It's kind of a pre-trained, right? And still we need to go one step further and do analysis with given other attributes or given other properties of the customer, right? And then only decide. See, right? So to train the model with the data, like human, it cannot learn from the experience, right? It needs the data to learn the pattern. Once it learns the pattern, that's it. Right? You can use this algorithm, right? You can show the new person who applied for the loan to this algorithm. It can tell automatically, hey, this customer is a good customer, this customer is not a good customer, don't give him loan, don't give him loan, give him loan, give him loan. Though this customer has pre-existing loan, but still he has the capacity to pay because his income is very high, and also he has secondary income also. Better we can give him one more loan, but likewise. And also you can use machine learning algorithm to predict the loss given data. In case I give the loan, and what is the in the event of default, how much loss am I going to incur? All these things you can do it with the help of machine learning algorithm. The simple idea here is, the central idea is, train the model with the historical data. The historical data should have both the input and output data, and then see the model, the trained model, you can use it to make a prediction of your unseen data, on your unseen data. This is what machine learning algorithm is all about, in simple plain English. In the internet you can find different definitions, right? This is a very simple one. How many of you are able to understand this one or not?
Able to understand.
Very good, right? Simple, right? Okay. So this is how the machine learning algorithm works. Okay. But in the case of machine learning algorithm, we have right at the high level, 4 types of machine learning algorithms are available. There are 4 different types of algorithms are available. One is supervised machine learning, supervised machine learning, and second one is unsupervised machine learning, and third one is like this one, supervised, unsupervised, and then semi-supervised, and fourth one is reinforcement learning. These are the 4 different types of machine learning algorithms are available. Now let us start look at what is supervised machine learning algorithm. As the previous example, as I mentioned in the previous example, right? This is a supervised machine learning algorithm. Why it is called supervised machine learning algorithm? In the case of supervised machine learning algorithm, we train our model with the historical data, which has both the input and output, age, income, and marital status, and any pre-existing loan, right? So pre-existing loan. Likewise, right? Different column, marital status, and number of kids, and his income, right? And any secondary income, whether he has asset details also, right? Whether he has any vehicles or something, right? All these things. When you go for a loan, they'll ask everything, right? Pre-loan, pre-existing loan, everything. These are called your independent variable. These are called your independent variable or input variable. Usually in machine learning, we use the term called features. Features are nothing but the input variables. Features are nothing but your input variable. These combination of features helps us to determine the capability of the customer, right? Let's customer name, right? Customer name or customer ID or account number 1, 2, 3, right? So this here you have something called profitable. You have a column called profitable customer. Here, based on their past performance, right, you would have mentioned whether this customer is a profitable customer or non-profitable. What do you mean by non-profitable customer? They never defaulted. These customers are defaulters. So, giving the loan to these profitable customers will make sense, right? So, the combination of these input variables, right, you are flagging this one, right? So, this one is determined based on the combination of these columns, right? Maybe his income is very high, but he is too old, and his loan amount which he applied for is very high, right? But still he is too old, but he has no asset, but his income is good, marital, but pre-existing loans are more, right? He has no, but the risk is very high, right? Likewise, the combination of the set of features, the profit, whether the customer is profitable or not, is determined, right? For this, you need all these data here. Okay, so this is called your labeled output variable. Labeled output variable. The input variables are called your features. This is called labeled variable. All right, labeled variable. Okay, so you need to have both input as well as output. Like how we teach a kid, right? We show something, and then if this is the thing and this is the output, right? If an elephant has, if an animal has a big ear and big trunk, right? Tusk. That means this is a pattern, right? So this is called elephant, right? This is called your features, and this is called your label, right? So the label is determined based on the features, right? Similarly, these are the features. Based on the combination of these features, we define this. Also, this is based on the past, performance, payment behavior. We noted down everything, right? With this, we train this machine learning model. This is my model. We train with this. We are training this model. Okay. Since we are teaching this algorithm with this, both this input and output data, right? We are supervising this, right? If so and so thing, and this is the thing, right? We are giving both input as well as the output to this algorithm, right? Since we are giving the input and output, we are supervising this algorithm, and also we tell the algorithm to predict whether the new customer is a profitable customer or not, right? New customer, say he applied for a loan, right? But we have his other details, features like age, income, all the things. But this is the first time he is applying for a loan, but we don't know whether he is going to be a profitable customer or not, right? Whether I can approve the loan to him or not, I don't have any magic formula, right? But when I apply this trained model on his data set, my model will predict automatically based on the patterns learned from the historical data, right? It will say either yes or no. If he is a profitable customer based on his pattern, it will say yes, otherwise no. Supposing you have, let's say, 0.2 million customers, they applied for the loan. Okay, do you think you can go, see in this example I just mentioned only 3, 4, 5 features, right? When you look at the loan application form, so many columns are there. Let's say hypothetically 25 columns are there, and you have output variable also, and right, 0.2 million customers when they apply for the loan. Do you think you can go through each and every customer's application form manually? Anything manual can lead to some mistake also, right? Sometimes you might tend to due to error, right, due to due to tiredness, right, you might ignore, right, due to oversight you might tend to decide whether you might tend to decide wrongly a good customer as a bad customer also, right, because of the oversight. Right. So and also the number of customers or number of records are very high. 0.2 million customers, they applied for the loan across India. So in that case, if you do it manually, it requires more time to find out of these 2.2 million, how many of them are good customers, how many of them are bad customer, and also it requires more staffs. Right. If you take more time, also the risk is very high, because your competitor banks, right, the rivalry banks are ready to offer the loan because they have sophisticated machine learning algorithm, robust sophisticated algorithm. It can tell them in a matter of seconds nowadays. Okay, with Hadoop and all, right, it can tell it can make a prediction in a matter of seconds, even if you have 0.2 million, 0.5 million customers, right? In a matter of seconds, they will get to know. And everything is automated. They'll say, oh, this customer is profitable. Tuck, 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 they approve it. But if you take longer time, what will happen? The customer will walk out, right? Your rivalry banks, they will snatch your customers. Loan is a profitable thing, right? It's a profit to bank, right? The customer, those obtain for a loan, they are supposed to pay the interest along with the principal. Plus, if they mistakenly, they don't make the payment on time also, right? Unintentionally also, right? If they don't make the payment, they have to pay penalty, and they have to pay GST and all the nonsense things, right? In that way, bank is benefited. So, right, the point is, my model should correctly predict whether the customer is profitable customer or non-profitable customer. In order to predict, I need to train my model with historical data. The historical data should have both the features as well as the labeled output variable. My model automatically finds out the pattern. Oh, if the customer income is so and so thing, and if he's a thing, automatically, right, it finds the pattern, it applies the pattern on this data, new customers data, and it predicts whether yes, or if it is no, it will predict. Now the question is whether whatever my model predicts, right? Okay, before I come here, so do you think manually you can go through each and every customer application and validate everything? It is a time taking process. You need more steps, right? So that is where the machine learning algorithm is very much handy, and we use machine learning algorithm to make a prediction of any volume of customer in a matter of jiffy. Okay, so in this case, I train my model makes the prediction. Okay, fine, my model predicted and it flagged each and every customer as the corresponding output, like yes or no, something like that. Now the question is whether how do I know whether my model correctly predicted this customer as a profitable customer? My model assigned Y to this customer, that means this customer is a profitable customer. Can I close my eyes and give the loan? So what does it says, right? What is the assurance the model predicted correctly that this customer is profitable customer? Like human model, machine learning model can also sometimes can make misclassification sometimes. Okay, so instead of saying non-profitable customer, it wrongly classified this customer as a profitable customer. That is a second step, right? For that is where we do model validation, right? Validation, we have something called cross validation. That is nothing but the test data, right? We will see it later. So in the case of supervised machine learning model, we need both the features as well as the labeled output feature as part of our input, your historical data to train your model. So here we are teaching both, right? Input, if the so and so input, this is the output. We are like how we teach the kid, we need to have the labeled output also along with the input features. That is why it is called supervised machine learning algorithm. Right? And also in the case of supervised machine learning algorithm, we split the data, the historical data, into train and test split. Train and test data. Train and test data. This and all we will see it later. In the case of machine learning, supervised machine learning algorithm, we are very clear what we are going to predict. What is the objective in this case for my model? What is the objective of my model? My model has to predict whether the customers, right, whatever the customers they applied for the loan, right, whether they are eligible for loan or not, right. It has to assign yes or no. It has to assign the class label. It has to predict the class label. This is called class label, right. So it has to predict the label for the customers, right. So that's predicted. So we know what my algorithm has to predict. Okay, so let's say I have another type of machine learning model, which is unsupervised machine learning model. So in that case, right, unfortunately I don't have this column. Labeled output variable is not there. I joined HDFC Bank as a data scientist, they gave me this data, but they did not give me this, right? So only this data. So if I have to assign the variable, it will take longer time, right? But the management expects me to see some interesting pattern from this given data, right? In the case of unsupervised machine learning algorithm, we simply source these features to this algorithm. We show these features to this algorithm. This algorithm self-detect the patterns from your data automatically. Self-detect the patterns automatically. What do you mean by pattern? Can someone give me some example? Arun Kumar, you can tell some pattern, right? Because you are into bank, and you can tell me some pattern. So how can you get to know the whether the customer is a good customer or bad customer? Let's say while talking to the customer, right? What patterns helps you to find out whether the customer is a good customer or bad customer?
First of all, what are all the transactions he is doing. If he is doing transactions more than his income, so he will not be able to make the payment. So that will be the first step we will understand.
Super.
And how much loan he has currently. For example, if he is having the loan of close to 15 lakhs, and monthly EMI itself he is paying close to like 40,000. His income is probably like 75,000. We will again think how much can we give him.
Yeah.
So the outstanding overall loans he is having. Then we will check the previous repayment history. Last 2 years, how his repayment history was there. Whatever is the check bounces or ECS bounce, or home loan ECS bounce, how much he has done it. That we will check.
Mm-hmm.
So considering these factors, and how many times he has that will be the last option. How many times he has changed his jobs, and how much salary hike he is getting every year. So probably we will figure out whether we can give the loan or not to this particular customer. If he is really coming under a good customer bucket, we will offer all the loans like home loan, housing loan, car loan, everything we will offer, and he'll be keep on getting SMS that you are eligible. Like
okay, that. I have an interesting question for you. Okay, I have a pattern something like this. The customer is keep on hopping the job and he spend like anything, and his loan is also, he borrowed money from various loan also. Okay.
Yeah.
And now he got a break with a good company. He joined with Google. Okay. Recently, his CIBIL rating is very bad, and he joined with Google. His salary is almost 200% more than what salary he was getting it in the past. So in that case, will you give him loan or sorry? This is outside the topic I'm asking.
Yeah, no problem. We will see his last 2 years trend.
Okay.
The last 2 years, kind of it is a little shaky. We will not give a higher loan. We will again check. There is another. Now the option A is over. Option A is we are checking last 2 years. So we will not give higher loans. Probably like if he is planning to buy a house for 50 lakhs, we will check. We cannot predict this guy. 50 lakhs loan he cannot pay probably in 5 years. It requires more time, like 15 or 20 years time requires for 50 lakhs loan.
Correct.
So now home loan will not be eligible. But how is this guy doing in the last 6 months? If there is no check bounce, kind of CIBIL rating is at least 700 plus. CIBIL rating should be at least 800 plus for a good CIBIL rating.
Okay.
750 is fair kind of okay. 700 is average.
Okay.
If it is below 700 we cannot go. If it is above 700 or above 750, yes, we will go. For normal loans, auto loan, personal loan, yes, we will definitely go ahead.
Superb. So, okay, thanks for sharing these things. So these are all pattern. The simple pattern as pointed out by Arun Kumar, right? So if a person spend more than his income, right, that's a clear indication. That's a pattern, right? The chances that he will definitely default. Obviously, if a person spend more than what is income, right, definitely he's going to default. This is a pattern, example for a pattern. And from the retail point of view, can someone share based on your experience? How about Harsha? Give me some example.
Yeah, like Satya, like for when coming to product analysis, how his purchasing behavior we will be seeing.
Mm-hmm.
Like if he is taking like 2 or 3 products at a time,
Mm-hmm.
so like that, likewise we will be seeing.
Okay. Apart from this, anything else? Like we just check, right? So let's say we have a few potential customers. We could see that these potential frequent these potential what do you mean with potential? These customers are frequently purchasing from my shop, and their amount spent is also more than so and so, and their return is also very less. They are not returning it more frequently. Okay, so they are potential customers. Okay, but of late we could see these customers are not purchasing frequently. They are not purchasing it, right? There could be a number of reasons, right? Probably now you would have got married, right? Because of which his expense would have gone high. A number of reasons, but I have 1,000 customers. I could see that they are potential customers, but of late we could see the last 2 months they spend is very less, very very less. This is one pattern, example for the pattern, right? The frequently purchased, how many number of times the amount spent, right? We could, with that we will be fine. We will be able to find out the pattern of the customer. The customer is another example is like in the case of product based or service based company, right? Let's say simple example, you are doing tank cleaning. Every home you go and clean the apartment, you clean the tank, right? So you have a lot of customer base in Chennai, and of late, right, your customers are dwindling. They are not coming back to you. They are not calling you for the next turn. Okay, actually this month they are supposed to call me for the cleaning. They are not calling me. Why? Because they are not satisfied the way how we did the service, right? They gave already one warning. In spite of that, second time also, right, I repeated the same thing. Obviously they moved to some other customer, right? So now these are the pattern. When the customers are not calling me, I knew very well this is the due date. They are supposed to clean the water tank. You must have you must be receiving this one, right, in your mobile also, right? Let's say somebody is using contact lens, right? It will say you purchase for 3 months. It is due for you to buy new contact lens now, right? And again, in the case of medical, right, you purchase these medicines. It is due for this month. When my mom was there, right, I used to purchase certain medicines in the Apollo pharmacy. They promptly remind me. So your medicines will get you will be running out of the medicines for the next week. So you want to order it? Can we ship it? Something else. A message will come. I don't know how many of you used to get this one. I used to get this message. Okay, so with the help of the pattern, right? The pattern tells us, oh, this customer used to order every once in a month. This month, so and so day, they are supposed to make the payment, right? They are supposed to buy this product, right? So something like that. Okay. So these are the patterns, and these are the patterns. Using the pattern, we get to know by mining this pattern, right? The algorithms helps us to understand how so and so behavior of the customers. So what we need to do is we need to call why these customers are not buying it frequently, like how they used to purchase in the past. If it is 1 or 2 customer, it's an exceptional case. Probably he would have lost his job, or he would have got married. But almost 10,000 customers, now they are not coming back to me. Even though they come to me, their purchase volume got reduced drastically by 60%. Okay, now they are purchasing only 30%, right, compared to the past. So maybe something wrong. Maybe our pricing strategy is not good. Talk to the customer, find out what is their So in the case of unsupervised machine learning algorithm, it self detects the pattern automatically, right? Now you understood what is a pattern, right? What is a pattern in simple terms. Some people, they don't even understand what is pattern. So the machine learning algorithm on our behalf, it automatically detects the pattern. But in the case of supervised machine learning, we need to tell both the input and output. But whereas here you don't have to give the output, like label output data, you don't need it. You can simply take the input data and then you can pass it to this algorithm. It self detects the pattern. Simple example is right, when you pass the data, it plots something like this, right? So these customers are high income group customers. These customers are medium income, low income group customers. Something like segment. It segments the data. It automatically profiles the customer, right? So it detects the pattern based on the their salary and other thing asset, right? It finds out the pattern and it segments the data like this: high income group, medium income, low income group, something like that. And what is semi-supervised? Semi-supervised is an hybrid of both supervised and unsupervised. And reinforcement learning, this is the one used in self-driving car. I'll explain these two later. If I explain you now, you will be overwhelmed. Okay. So as of now, you understood what is supervised and unsupervised, isn't it? Next, in the supervised machine learning algorithm itself, there are two different types are there. The supervised algorithm, at a high level, we solve two problems. One is the regression problem, other one is classification problem. Regression problem and the other one is a classification problem. What is a regression problem? Sorry. So in the case of supervised machine learning algorithm itself, there are two types. One is we solve two different problems at a high level. One is regression problem and the other one is classification problem. Okay, so what is regression problem? What is classification problem? In simple one-liner, to predict a target variable, which is of numeric, stock price, right? Classification problem, the same thing, to predict a target variable which is of categorical. Very simple, isn't it? To predict a, what do you mean by target variable? I told you the labeled variable, right? That one. To predict a target variable which is of categorical is called your classification.
That's basically the output, right, sir?
What is it?
No, the target is basically the output, right?
Yeah, output variable. Yeah, to predict the output variable or target variable, right? So in this case, we predict like I told you, right? In the case of bank loan, right? The model will predict the target label. Model has to predict the target label, like yes or no, right? The target, the label, the target output variable. You can say target or output variable. It's all same. Yeah. Good, you said this also, right? You can say either target or output variable. So to predict a simple term, right? To predict the output variable which is of numeric, to predict output or target variable which is of categorical, right? We call that as a classification problem. So any example for example, I want to predict the housing price. Housing price is numeric variable, right? Predict the housing price. I want to predict the housing price. Okay, I want to predict the stock price. I want to predict the return on investment, right? Loss given default. I want to predict the loss given default. Okay, in the event of default, how much loss the bank can incur, right? So these are all the numeric variables, right? These are all the numerical variables. We are predicting it, hence it is called a regression problem in simple one-liner. In the case of categorical variable, in the case of classification problem, the target variable is of categorical, right? Categorical. So in this case, we predict whether the customer is going to default, it has to predict the class label. It has to predict the class. So predict the, in simple term, it has to predict the class label as well as probability also. You can predict the probability also. In our day-to-day life, we use percentage. When it comes to statistics, we use something called probability. Probability value ranges between 0 to 1 only. If somebody says the probability, there is a 0.8 probability I will get promoted this time, 0.8 probability. Any value which is closer to 1, that means the higher likelihood. Right? There is a higher likelihood that I will get promoted. If you say 0.2 or 0.3, there is a lesser chances that you will get promoted this time. Right? So you can predict the class level, and also you can predict the probability also. For example, my model says a customer is going to my customer is going to be a profitable customer. It says yes, but still like Americans, right, always they expect us to quantify. If you say anything, right, can you quantify that? They'll ask this one. So okay, this is the predicted label. My model predicted this customer is a profitable customer. So what is the probability that is going to be a profitable customer? Can you quantify? Yes, that is where the probability. And you can also make a we can predict the probability also along with the class label. My model will, let's say my model assign the label for a customer as Y. That means this customer is a probability customer, right? But I wanted to quantify this one, right? That is where we can use the same classification related model to predict the probability also. Let's say the probability 0.6, 0.58, 0.55 probability, right? The probability is 0.5 probability. This customer is, my model classifies is a profitable, but he is not very good customer, right? With the help of probability along with the predicted class level, we will get a better idea. He is a profitable customer, but the probability of being profitability is or non-defaulter, right, or defaulter is 0.55. You can predict the probability. You can. Okay, in the case of categorical, we are going to predict the class label, and also we can predict the probability. Fine. And so in this case, we are going to predict the class label either yes or no, right? So let's say I have a column called profitable. This column has either yes or no, right? Only two classes are there. Hence it is called a binary classification problem. Binary classification problem. You studied this term, right, during school time. Binary means only two classes are there, right? These two classes are mutually exclusive. Predicting the binary classes using your machine learning algorithm is called your binary classification problem. Let's say I have multi-class classification, right? So multi-class we have something called multi-class classification. Multi-class classification, okay. So if you have more than two classes in the target variable, we call that a multi-class classification thing, okay, multi-class classification. And we have something called multi-label classification problem. We have something called multi-label classification problem. So I'll just write it and see. In the case of classification, what is a classification problem now? In the case of classification, we have something called binary classification problem. And we have something else called multi-class classification problem. Number 3 is multi-label classification problem. So now in your target variable, if you have two classes, yes or no, let's say you have a column called profitable. This customer is a profitable. If it is yes, is a profitable. N means is non-profitable customer. So it's a binary classification problem. You will not have more than two classes in this column. You have multi-class classification. So in this case, let's a model has to predict something like fruit name. For example, a model has to predict the fruit name, right? If it is, let's based on the shape of the apple, okay, a round color and red colored, color is red, and the shape, color, shape, and taste also, right? Taste is some taste, right? So if the taste is this, and if the color is, if shape is this, then this is called apple, right? So apple, orange, and here's something called pineapple, custard apple. You have more than 2 classes are there in this target variable. Your model has to predict with the given these 3 variables, right? It has to predict whether the given image is apple or orange or pineapple or custard apple. So this is called your multi-class classification problem. What is multi-label classification problem? Classic example is movie, right? So let's say you watch, you are given a task of classifying a movie with the multi-label. Okay, so whether a movie is comedy, it's a comedy, and it is a romantic movie, right? It is a romantic movie, right? So comedy and romantic movie. Movie is romantic as well as it has a comedy in it. Very good. This movie is very good. So here you assign 2 labels here, more than 1 label, right? More than 1 label. Hence it is called multi-label classification problem. Okay. So you have something called tragedy, and you have something called lot of you have something called fight scene is there, right? Lot of fight is there. So it is a fight and tragedy. It is not that good, right? So this movie is like this. This is a different. We label certain instances or records. We can assign more than 1 label also, right? So that is called multi-label classification problem. Okay. So now you understood what is a regression problem. Is very simple. If you want to predict any numerical variable, right, in simple term, we call it a regression problem. In the case of classification problem, usually, right, we 80% of the time we solve the binary classification problem only. Okay, and the multi-class classification problem also, right, nowadays we solve this one also almost 25% of the time, right? And multi-label, so in the case of Netflix and all, right, they use this multi-label classification thing, right? They classify the movie as comedy, romantic, and more than 2 label also. It can sound, certain cases you can have more than 2 label also. Don't think just I mentioned 2 labels, it is a multi-label classification. You can have more than 2 labels also, right? So this is called the classic examples. Netflix, right? Netflix, if you go and watch movie, right? So when you see the review or when you see the movie, they would have mentioned as comedy and romantic, tragedy, and you have something called murder, right? So murder or something, fight scene, lot of fight is there, and action film, right? Action film, you have something called fight will be there, more fight will be there, right? And some amount of comedy will be there, right? Some in the action film, you just think that way, okay? In Tamil film like that, right? Action movie will have some kind of comedy will be there, but romance will not be there, right? So likewise, right? You can have more than 1 label for some instances, some records. Okay, that is what this is the example for multi-label classification. Okay, and your model has to assign more than 1 label in this case. Okay, so you are very clear with the regression and classification problem as of now, right? So the next one is we will see what is regression, how we can solve the regression problem. So we know what is a regression problem at a high level, right? At 60 feet height, we understood what is a regression problem, to predict a target variable or output variable which is a numeric variable, right? Fine, that is what your regression problem. You can use many algorithms. A lot of algorithms are available to predict the numeric variable. So you can use linear regression. You will be using linear regression. You can use decision tree. decision tree algorithm, and number 3 is neural network, and number 4 is support vector machine. This is vector, okay, vector machine, and k nearest neighbor. Likewise, the gamut of algorithms are available to solve the regression problem. Similarly, in the case of classification problem also, we have the decision tree is used, neural network, support vector, and k, and all these algorithms we can use it to solve the classification problem also. Okay, so this is kind of a dual purpose. You can use these algorithms for dual purpose. You can solve regression or you can solve classification problem. But linear regression algorithm is meant to solve only the regression problem. Okay, and in the case of classification, you have something called logistic regression. Logistic regression algorithm is to solve only the classification problem, like linear regression. So you can solve only the classification problem using logistic regression. Using linear regression, you can solve only the regression problem. Right? So these algorithms, you can use it for both purposes, regression as well as the classification problem. So I will teach you, how to implement, how to tell the decision tree whether it's a regression problem or classification problem. That I will teach you, how to tell the algorithm it's a classification regression. So anything is right in the target variable. If you specify the categorical variable, automatically the tree this algorithm will think, right, it is a classification problem. If you use a numerical variable in the target, it will think, oh, it is a regression problem. That's all. Okay, not much difference. But anyhow, there are other things are also there. We'll discuss it when I cover these algorithms. Okay. Before we dive into, we'll start with the linear regression. Okay. We'll start with solving a regression problem. Right. As I told you, to solve a regression problem, many algorithms are available. Usually, we'll start with linear regression algorithm. Okay, linear regression algorithm. Linear regression algorithm is very good, even though the accuracy is not so good compared to the advanced algorithm like XGBoost and other things, right? But this algorithm is very much intuitive. That means using linear regression, you can quantify. You can do what if kind of analysis with the predicted output value. Okay, so that is the one benefit of linear regression algorithm. Okay, so before we understand the linear regression algorithm, let's try to understand certain jargons. Independent variables. As I told you, the features are called your independent variables. Features, right? In machine learning world, we use the term called features. Features are nothing but independent variable or input variable. As I showed you already, right? Input variable. Some people, they call it as a predictor variables. Because you should be knowing these terms. When you attend an interview, you don't know what kind of terms he is going to use, right? What kind of jargon that is. Input variable, predictor variables, input variables, and independent variables. Okay, and some people, they call it explanatory variables. Okay, explanatory variables, and some people, they call it regressors. Okay, so they use different terms. Okay, don't get confused with these terms. This is right, independent variables, input variables, predictor variables, explanatory variables, regressors. Okay, so what we will do is, instead of using these different jargons, right, I'm going to call it as a features. But most of the Americans, they use this term, features. Okay, but still our guys who is working with Americans, right, they use different terms. Okay, that's the reason why I put all the things. And also interview, you do not know what term that they use it. So the target variable, the output variable, right, labeled variable. So label. What is your, they say label, right? So what is your label name, right? So it is also called as output variable or target variable or dependent variable. From the statistics point, right, we use dependent and independent variable. Because this variable is depending on other variable. Simple example, housing price. Housing price is a dependent variable. It's a dependent variable. Why? Because the housing price is depending on the size of the house. Square feet, right? What is the size of the house? Housing price is depending on these variables. Hence it is called a dependent variable. Size and age of the house, right? Older the house, the housing price will be obviously less. Newer, brand new
Part
house,
of the city also.
yes, right? Your location.
Out of the city or inside city.
Very good, right? Location also matters, right? So location, age of the house, and likewise various other these are called your independent variables. So the dependent variable, right? This is the one is depending on other variables, right? But these variables are independent of one another. It is not depending on any other variable. Hence, this is called your independent variables. Statisticians, they used to use these terms, independent variable, dependent variable. But now, right, so what is your predicted label? Can you tell me? So what are the features that you used it, right? You should not get confused. That's the reason I used all the jargons here, okay? All the equivalent terms. Got it? So maybe, yeah, my handwriting is not good because I want to write it fast. I want to cover more, okay? That's the reason why I write it fast. But anyhow, I will not rush. So now you understood all these terms, right? So what we will do is, right, since today being the first session, right, I'm going to wrap up, with this one. But anyhow, don't worry, in this batch we'll cover many algorithms as per our deep learning also, right? And don't miss out the upcoming sessions, right? Even though you need to create some time, right? In case you are not comfortable, you tell me, I'm not comfortable with this time. Is there any way can you work out with so and so time? You tell me, we'll plan it accordingly, right? There is no hard and fast rule, right? So we will see to that. Accordingly, we will, set up the time. But point is, don't miss out anymore. So far, it is good. See, Python, you can learn it. See, certain algorithms, I will tell you, right? So, for example, back propagation. You have something called back propagation. That uses, in the case of back propagation, you will have to understand what is partial derivative. And the question is in interview, right? If you understand only partial derivative, that is not sufficient. Then they will ask you, why to take partial derivative? Can't you take the derivative directly? They can ask you any number of questions, right? And then ask you what is derivative, what is partial derivative, why we need to take partial derivative, and why we need to first of all do the back propagation. How does the back propagation algorithm works? What is chain rule? And what is, in order to implement back propagation algorithm, you should be knowing the sum rule. You should be knowing the calculation, the calculus part, which is nothing but the derivatives. And you should be knowing the power rule, sum rule, all the things. But you don't have to spend 1 month or 2 months to learn all the things. Don't waste time. I will teach you everything as part of the algorithm itself, so that you will be able to understand the relevant mathematical formulas. That is enough. And many people, I could see that, they will create anxiety with the aspirants, saying, you need to learn mathematics, you need to be good at this, that, they will get, scared. Don't worry. The point is, right, the crux of my point is, you cannot learn algorithms, but you can learn it from the internet. Many videos, you need to refer many videos, because you cannot expect what question the interview will ask. See, nowadays it's not like what is what. They are not going to what is linear regression, they will not ask just like that, right? They will ask you, questions, every answer to the interview, right? Whatever the answer you give it to them, right? That leads to another question. If you say, I took partial derivative, can you tell me what is partial derivative? Why should I take partial derivative? Can't I take derivative? So they will say, okay, partial derivative, we take it in order to know the change in the cost with respect to the coefficient value, right? But they would have known only this much. Why you need to take partial derivative? Can't we take derivative, full derivative? They'll get confused, right? That's the reason why don't miss out any. Certain things you can learn it from the internet. Certain things, yes, you need more help from me, right? That is the reason why you need a guidance. Okay, don't miss out any session. All right. So anyhow, next weekend we will circle back, the same time. Not same time, we will see, right? We'll check with you all based on the convenient. Ideally, we will have it in the evening time, right? So 7:30 to 9:30 if we have it, or 7 to 9, right? You can go to bed early, or you can celebrate your weekend in the night time, right? That way we can plan it accordingly. All right. So anyhow, I am running out of time. I thought of spending some time for FAQ as part of each session. Today I am getting more calls. What we will do is, if you have any questions, you send it to me. Otherwise, we will start with FAQ, the upcoming weekend session. Okay, don't worry. So I'm going to wrap up the session. Okay.
Sure,
Good night.
thank
Take
you.
care. Yeah.
Thank you.
Yeah.
Thank you, Satya. Thanks.
Bye.
Thanks, Satya.
Okay. Good night.